Interestingly, we can talk about machine learning and its purpose, with it being kind of the current hot thing in the technical world. Everybody's jumping on the bandwagon and let's say, let's do machine learning. We need predictive something or other in our little one-off phone application or something like that, right? You probably have heard that. Um, Machine learning by itself can be quite expensive. Expensive in terms of infrastructure and computing resources. Basically, you need a lot of data. You might need a lot of processing time to understand that data. There's a lot of time involved in labeling it and making sure that your model is doing what you say it should be doing. Right? You have to prove that your model works too, right? You can't just train a model and expect it to work perfectly. And heaven forbid you apply that to something safety critical where human lives are at stake. You'd better damn well be making sure that model works in that case. But if we are doing simple applications, it's not necessarily useful. I mean, it's useful, but cost-wise, it's not maybe the best decision. So if you're doing something to save money, might not be the best idea. It can be quite costly, and costs can be hidden or latent, right? But if you are scaling up, if you are making loads of decisions for hundreds to thousands of devices at any given time, then perhaps it does make sense. So this is kind of one of those things where you have to kind of step back and realize, do we actually need to go down the route of machine learning? And if you don't, then maybe it's not the best decision. But if you have this notion of scale, then it can be helpful. So interestingly, with machine learning, it used to be a very, very difficult process. So you had to be an expert in matrix math. You had to be an expert in learning-based algorithms um, like neural networks, like deep learning. Basically, all of that subset of learned behaviors and modeling and predictive analytics, you had to be an expert on. But now, with a lot of these cloud resources, and Google's not the only player here, right? All these barriers to entry are basically being removed. So if I want to do very basic machine learning where I just have data and I want predictions, I don't have to write a single line of code. I can just grab one of these pre-baked models where as long as it aligns with my task, say speech transcription or image recognition, I don't have to even understand how the model works. I can just upload data. And to me, that's almost a scary thought because if we don't understand what the algorithms are doing, how can you guarantee that it will always work for you? But basically, there's an entire branch now of basically cloud computing where we can go infrastructureless and platformless and softwareless. We're just importing data. Um, Algorithms have become standardized, which is very nice as well. We don't have to hand construct a machine learning algorithm. We can just go out and say grab ResNet for image classification. And if you do want a deep dive into some of the software behind it, or even the hardware, there are there are programming modules like TensorFlow that are out there where it's very, very easy in something like Python to get up and running with machine learning. So, how can we take this and apply it to the cloud then? So here we're going to have a running example now of detecting diseased leaves on trees. And basically what this is going to involve is taking pictures with your phone and trying to figure out, is this a diseased leaf or not? And this can be a very, very, useful application where we need to figure out automatically. Let's say that you want to give this to, a research assistant in the field. They're not programmers, but they're very good at working with nature, right? They're very good at being out in the woods. Is this diseased or not? Maybe by eye you could detect that. Maybe it's really difficult. There's a lot of latent things that could feed into this. So what do we do here? If we are going to go through this kind of example, we obviously need a data set, right? So let's get a whole bunch of images of these leaves, diseased, good, all the gamut in between, and let's label them. So we are basically going to feed a machine learning algorithm with pictures we've taken in the field. And ideally, based on this data set, we can now have an application which you just take a picture with your phone, or any people you're working with, just take a picture. This is diseased. Treat this tree. Okay, well, this could feature in with something called AutoML, which is one of Google's cloud services, where we are basically going to be taking all of the heavy lifting of machine learning off of you. And based on what AutoML spits out, you're going to get a RESTful prediction. So your phone application, your cloud service, whatever you're doing, we're just spitting out a RESTful call. So IP address slash is diseased slash true. That could be a RESTful prediction. Right, so what do we have available to us? Um, the figure you see in front of you here are basically the three categories of machine learning that you can do, at least up in Google Cloud. Again, Azure and AWS has their own variants of this. I think AWS has like SageMaker, that's their AutoML, I believe. Um, Honestly, I'm not sure what Azure has, but I know they have very similar possibilities too. So on the left here, these are your pre-trained models. So you don't have to do anything here. You could call the Vision API and have it detect logos. You could have it detect objects. This is basically using everything that Google knows. They have pre-trained models for this. So if you go out to the speech to text API, you can literally go to the speech to text page, turn on your microphone, and have it spit out text. Basically, we are using all of the power that Google has already put into this, all of their data centers, their data collection, everything they've done. They have these models being constantly trained and updated, and you can just leverage them. Right? If you want to do translation for your cloud application, you want to translate from English to German, you want to translate from German to Italian, translate to any language supported. You don't even have to provide the training set. You can just input your data and you can get a response out of it, which is very, very powerful if you just want to use somebody else's resources. Now, obviously, you pay for this, right? But that would factor in with your project planning and your costs that you have to use. Maybe, though, you want to go a little bit more customizable route. So if you want your own data, this would be AutoML. So this is the figure we saw here where we are training this diseased leaf data set with AutoML. Now, the machine learning algorithms under the hood, we don't have to worry about. This is the middle step in between. And we can make use of some of the standard algorithms here, like image classification, language translation, data predictions, things like that. But we feed it our data. We label our data and tell AutoML, this is good, this is bad. Or if you are really good at, sorry about that, if you are really good at machine learning and you understand how it all works, you could go TensorFlow, which is a library, and there is tensor based, it's tensor processing units or TPUs baked into a lot of data centers that are really good at handling tensors. Um, Basically, you can use the power of their data centers. There is AI platform as well. Basically, we have a wide range of capabilities here. So just for fun, and I want to go to Google Speech to Text. So this is their cloud tool here. I can just say microphone, and oh, hello there. How are you doing? See, there's my text right there, speech to text. I have not trained anything. I have not done anything. And this is obviously their little sampler that they have, right? This is not necessarily um, something you could really make use of, but this is an API that you could call. Okay. So that'd be one of their pre-trained models. And I've got some examples for you for some of these fun things that we can work with. This is another fun one. Highly recommend you check out. So there's this quick draw. This is a machine learning image classifier. Not going to go into it here just because I want to keep this set of videos relatively short, but it basically recognizes what you are drawing as you are drawing it. All right, so um, now going a little bit deeper into it, deeper, great pun here. Um, AI tends to use deep learning under the hood. That was the kernel of our machine learning and then AI figure before, right? And what we're trying to basically do is make predictions and to train a model based on, what we understand from a data set. And here we have a deep neural network where, again, the goal isn't really to go into how to construct this or what it is, but basically we're going to have a set of pathways for our decision to occur. And based on data that we process, we're going to activate a bunch of neurons along the way. And neurons are basically just little mathematical transfer functions. Go this way, activate, deactivate. Um, a lot more to it, but we kind of work our way through this network here, and then we get a decision at the end. Is this a cat or is it a dog? Do we activate our right turn in our Roomba, or do we go straight, or do we stop? And basically, we are just making predictive decisions by training a network to activate a set of pathways based on input data. Right? If our Roomba example detects that there is a child in front of it, it should stop, right? Well, how do we know that? We have trained a model in such a way that the correct pathways activate when a set of inputs are detected. Human child or pet or obstacle in front of us, stop. So there is a kind of a few playgrounds that you can work with here. There's the TensorFlow playground where basically you can play around with these neuron layers, play around with activations, maybe add extra layers, and you can really get a better feel for what tensors are, what deep learning actually involves. Would highly recommend you play around with this just to kind of get a feel for all the under the hood type of stuff that is honestly abstracted away in a lot of these cloud resources. So if you want to understand how computers think and how they make decisions, this playground is kind of a fun thing to mess around with.